We want to look at matrices and determinants. Definition of matrices. Matrices are mathematical objects used to organize and manipulate data. They are composed of rows and columns, forming a rectangular grid-like structure. Each element within a matrix is called an entry or a cell. This is a matrix. It's in grid-like form now. The entries here, they are called elements. This is an element A, B, C, D. A, B, C to I here is also the elements of the matrix here. The order of matrices. This matrix has 3 rows, second row, and third row. The first row consists of A, B, C. Second row consists of F, E, D. Third row consists of G, H, I. First row, second row, the third row, and it has 3 columns as well. First column, second column, and you have third column. So, once a matrix has 3 rows, 3 columns, it's called 3 by 3 matrix. Okay? Now the first row here, first column here. This one is called first row, first column. First row, first column. This one is first row, second column. First row, second column. This one is C here is first row, third column. First row, third column. In this FA is second row, first column. Second row, first column. This E here is second row, second column. This one is second row, third column. And this one is third row, first column. Third row, second column. And the third row. So we can say the matrix. These are matrix become first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column, third row, first column, third row, second column, and third row, third column. So this is for the 3 by 3 matrix. We can also have 2 by 3. Let's say it has 2 rows. This matrix has 2 rows. Okay, if you want to name this matrix, yeah, we can say this matrix has 2 rows and 3 columns. We can name this matrix as 2 by 3. That is the order of the matrix. We move to addition and subtraction of matrices. To add or subtract matrices in the same way, we have 2 matrices here. We are asked to add them together. In this case, the corresponding elements here, first row, first column here, which is 5. First row, first column here, which is 1. They will be added together. So this is what we are going to have. We have 5 plus 1. Here, first row, second column. First row, second column. We have 1 plus 0. Here we have first row, third column. We have 1 plus first row, third column here, plus 2. We come to this place, so we can now have 2 plus 4, 3 plus 1, 0 plus 1, and 2 plus 3. We have 6. We have 1. We have 3. We have 6 as well here. 2 plus 4, 6. 3 plus 1, 4. We have 1 here. 1 plus 0, 1. 0 plus 7, 7. And 2 plus 3, we have 5. This is our final answer. If the subtraction it is also the same way, you just minus the corresponding values. If we are to multiply this matrix, we'll just use like this k multiply every element inside or every entry. So this matrix become ka, kb, kc, kg, kh, ki. Okay. Then let's look at the example of this one. We are to simplify this. To do this, this 3 multiply everything inside. 3 times 5, you have 15. 3 times 1, 3. 3 times minus 1, minus 3. 3 times minus 2, minus 6. 3 times 3, you have 9. 3 times 0, you have 0. 3 times 1, you have 3. 3 times 0, 0. 3 times 2, 6. This is the example of a scalar multiplication of matrices. Multiplication of matrices. This one has some trick that you just have to understand. In multiplication of matrix, row usually multiply the column. So the row will multiply the column. Let's say this is the row now. It multiplies this column. Okay? So we are having the first row multiply the first column. So we have our option to be here. The first row again multiply the second column. We have the first row 1, second column 2. Here also, second row multiply first column. Second row is 2, multiply the first column 1. And the second row here, multiply the second column here. We have second row multiply second column. This is what is going to give us. Now let's start with the first row to first column. Remember the first element in the first row, we multiply the first element in the first column. Second element in the first row, we multiply second element in the first column. So to multiply A, B, and E, F now, A will multiply E, AE, plus B will multiply F, BF. Okay? Let us do the first row, second column. First row, second column. A will multiply G, this first row, this second column now. A multiply G, we have AG, and B will multiply H plus BH. Now let's go to the second row, multiply first column. Multiply first column, that is C times E, CE, plus D times F, DF. We now go to the last one, second row, multiply second column. Second row multiply second column. C times G, CG, plus D times H, DH. Now we look at the example on this. We have to simplify this. The first row we multiply this first column. We have this, as I've explained before. So we have this one. The first row, that's 1A. Multiply the first column. This is also 1A. So we say 1 times 2 is 2. Minus 3 times minus 3 will give us plus 9. We have the first row, first column, 2 equals to 11. We have the first row, second column. 1 times first row, this is the second column. 1 times 1 is equals to 1. Minus 3 times 2, that's minus 6. Okay, your final answer is minus 5. Then we go to second row, first column, second row, first column. All right? 3 times 2, 6. 4 times minus 3, minus 12. So we have minus 6 as the answer. Okay? We now go to second row, second column. Second row is there. Second column here is here. 3 times 1 is 3. 4 times 2 is 8. So we have what? We have 11. So we can put it here now. The final answer here will be the first one is 11. The second one, first row, second column, that's minus 5. This one is minus 6. And this one is 11. This solve this. Then we'll move on to the another multiplication. Let us look at this example. Of course, this one is of order 3 by 2. 3 rows, 2 columns. This is 3 by 2 matrix. 3 by 2. And this one is first row, second row, first column, second column, third column. So this one becomes 2 by 3. Yes, you can multiply 3 by 2 by 2 by 3 because you know that a row that multiply column. Now coming to this, how do we go about it? Okay, for this, the first row will multiply the first column. We have this. The first row again will multiply the second column. We have this. And the first row again will multiply the third column. Now the second row, we take the second row, multiply the first column. Second row, multiply the first column. Second row, multiply the second column again. And second row will multiply the third column. Now taking the last row here, which is third row, multiply the first column. Third row, multiply the second column. And third row, multiply the third column. Now let's get the first row, multiply the first column. First row here, multiply the first column. Minus 1 times 2 is minus 2. And 1 times 1 is 1. So answer is equals to minus 1. Take the first row again, multiply the second column. This is the first row, the second column here. Okay. Minus 1 times 1 give you minus 1. And 1 times minus 5, minus 5. So the final answer is minus 6. So the first row, third column, minus 1 times 0, 0. 1 times 1 plus 1 give us 1. The second row, first column. Second row, first column. 3 times 2, 6. 1 times 1 plus 1, we have 7. Then we have the second row, second column. The second row, second column, 3 times 1, you have 3. 1 times minus 5, you have minus 5. So the answer is minus 2. Now we have the second row, third column. Second row, third column. We have 3 times 0, 0. 1 times 1 plus 1. We have 1. Then we go for, we have the third row, first column. 2 times 2 is 4. 0 times 1 is 0. We have 4. We have the third row, second column. Third row, second column. 2 times 1 is 2. Plus 0 times minus 5 is 0. This is 2. Third column. Third row, the third column. 2 times 0 is 0. And 0 times 1 is also 0. So the final answer is 0. We plug in all this into this. Then it gives us this. It gives us this as the final answer. Determinant of a 2 by 2 matrices. You have a square bracket, but this one, you have this straight line like this. It shows that it's determinants. Okay? So, and it means that the leading diagonal here, they multiply minus the other diagonal here. Multiply this, BD. Okay? This is the determinant of these 2 by 2 matrices. Now let's look at the example on it. We are asked to solve this. To solve this, since we have seen this line there, it means it's determinants. So here will just be the leading diagonal here, multiply them. So we have 3 times minus 1. This leading diagonal here, minus 5 times 4. So we have minus 3 minus 20. And that's minus plus. So we have 17. Okay, that is the solution for this. Now let's look at the determinants of 3 by 3 matrices. To do this, to get the determinant of 3 by 3 matrix, we have the sign convention plus minus plus. So we take plus A. We'll cancel the what? The column of A and the row of A. Then we are left with EFHI. Then we get the determinant of EFHI. The next, we go to the minus B here. Minus B. Yeah. This minus B here, we'll cancel the row of minus B, or we'll cancel the column of minus B. So we are left with DFGI. Then we go to the last one, plus C. Then we cancel the row of plus C and the column of plus C. So what do we have? We get the determinant of DEGH. So the final answer here for the determinant of the first one is A into bracket EI minus HF minus B into bracket D times I DI minus FG. And the last one is plus C into bracket DH minus EG. This is the determinant of 3 by 3 matrix. Let us look at example on it. Do not forget that I said that this straight line means determinants. Even if you are not asked, if you are not told, these straight lines mean determinants. How do we go about it? We have our sign convention, plus, minus, plus. So we write plus 0. We cancel this row, this column, and this row of 0. Then it remains the 3, 1, minus 2. Then we go for this, minus 1. Then we cancel the row of minus 1 and the column of minus 1. So we are left with 1, 3, 2, and minus 2. 1, 3, 2, and minus 2. Then we are left with this plus 2. The next one is plus 2. We cancel the row of plus 2. We cancel the column. So we have 1, 3, 2, 1. Then we continue with our work. 0 multiply anything here will be 0. We don't need to continue with that. Minus times minus 1 give you plus 1. Determinant of this one is 1 times minus 2 give you minus 2. Minus 3 times 2 give you 6. Then we have plus 2 here. Yeah? The determinant of this is 1 times 1 is 1. Minus 3 times 2 minus 6. Minus 2 minus 6 give us minus 8 times 1. You have minus 8. And 1 minus 6 is minus 5. Minus 5 times 2 give us minus 10. So the final answer is minus 18 for the determinants of this. Thanks for watching. This takes us to the end of the first part. You watch out for the second part.